So for the first question, I basically saw that it was digit sum, and you're trying to find like what is the earliest digit sum you can get that is also equal to your I index. So to do this, I basically decided to go for a for loop to iterate through all of the numbers in the numbers array that's given. I was also going to make like a separate function thing to find the digit sum, but then I decided like whatever the heck I was trying to do that night that it was just easier to do like a one-liner inside of the for loop instead. Yep, and then basically I use some Lodash functions that are just built into Leetcode. So I ended up doing kind of the messy way since it's an easy problem. So like a sum by of the current number that I have, I convert it to a string. So now I can like split it into characters, and then I can take those characters and sum them up together. Of course, this led to an issue where because I was converting a number to a string, and then that string to a char array, it was considering them as characters instead of numbers. So I wasn't actually getting a correct digit sum that I could compare to I. Of course, since I code in JS, I kind of shoot myself in the foot with type safety there. So the I would be a number, and then whatever I was trying to do was like returning a string that obviously was not going to be correct. So that's why I kept receiving -1 instead of like what I would expect the answer to be. But then eventually I figure out like, hey, I was being a dumbass and I forgot to map like everything back to being a number because I was doing it in this really messy way. So yeah, as soon as I convert it from like a character data type using the JS map function to a number data type, it was pretty much smooth sailing from there. I was able to do accurate comparisons, and I was able to return the earliest possible index for solving that problem, returning the earliest possible I. And then of course, if I don't like come across like the earliest possible I, or if there's never a point in the array where your index of I is equal to the digit sum that you have of that number that you're evaluating, then I just like simply return -1, and that's basically how you solve it. So this problem definitely gave me hope, right? Very easy beginner problem, solved it in about like 2 or 3 minutes or so. The rest of the contest, though, oh my god, I kind of failed the rest of the contest, but we'll check that out when we get there. So of course, since the next problem also just so happened to deal with digit sums, I decided like, you know what, we better hunker down. This is a medium problem. I'm actually going to do a proper implementation using like mathematics and shit for digit sum. So here we basically just get a while loop. Each iteration we do like a floor divided by 10. And then like in between each iteration we also just get like the module of 10, so we can get each digit, add them to like a prefix running sum variable thingy. Then we get like an accurate digit sum that way without the converting the string and splitting the string bullshit. So yep, and then I read this problem a little bit more, and I saw that it dealt with digit sums, but it also dealt with like these swaps. So basically you're trying to return the minimum amount of swaps that you would need to like sort this given array in a specific way. So of course, naive little dev god last night thought like, hey, I know what I'm going to do. You know what sorting algorithm uses swaps? A bubble sorting. So yeah, that came to like bite me in the butt later, cause I really did fully assume that just doing a bubble sort would, I guess it would just like automatically give me the minimum amount of swaps if I just like counted each swap that the bubble sort algorithm would complete. That it would just give me like the magical greedy minimum amount of swaps needed to sort the array in this specific way, according to its digit DPs of each element in the array. Of course, now I know, like, post-contest, that the bubble sort does not guarantee you that. It is just a generic, like, log of n sorting algorithm that just so happens to use swaps, but it doesn't actually give you the minimumist, the smallest possible amount of swaps that you would need to sort an array in a specific way. Of course, that did not stop me for getting stuck on this problem for about an hour during the contest. So yeah, that is probably like the first part of my downfall. This contest was just the fact that I really did think that bubble sort would save my bacon on this problem. Also, I'm kind of embarrassed to admit this, and I'm surprised that the JavaScript runtime did not return any kind of error about this, but for the longest time, I had the frickin' digit sum, instead of it being like a function call, I was treating it like it was an array with like square brackets instead of the usual function call, whatever you call those symbols. So yeah, I'm surprised that it did not throw any errors about that when I was trying to like use a function like it was an array and just like throw an index at it. But yeah, so I quickly got that fixed. So yeah, and this should have been my first sign that bubble sort was not going to help me out with this problem, but even though I was console logging out my sorted version of the given numbers array, I was still getting like way more extra swaps returned as my answer. So the biggest one is, for example, test case 3, even though there was supposed to be only 2 swaps required in order to like sort the entire array, my bubble sort kept on returning that I performed 6 total swaps in order to get the array fully sorted. So I would definitely have to tweak the bubble sort algorithm a little bit. So yeah, being utterly confused why the bubble sort algorithm for question 2 wasn't working, I decided to just move on to question 3. Which was actually, you know, for compared to the other problems not related to digit sum, this is way more of a like matrix traversal kind of problem. So basically you're given this map that you can navigate. So it's kind of your usual thing, right? DFS, go from one place to another place, try to minimize your required distance you need to reach that place. A nice, like, somewhat big but somewhat small matrix size. And of course you have like empty slots you could go into, can't go out of bounds, you could collide into walls. Your very usual like Dijkstra's matrix or your DFS, whatever you call it, matrix kind of problem. But of course this one is a little bit different because of course it is for the contest. This one has teleportation points. So of course like what I decided to do to start off the problem is just like the very boilerplate stuff you can do to get started with matrix traversal problems. So I just have like a function to check if I'm, you know, going to go out of bounds of the matrix, or if I try to visit an already visited space. So that's like kind of your matrix 101, is you can have a check bounds function, and then you can also use like a JavaScript hash set to check if you've visited like previous locations in your matrix, so you don't have to worry about infinite looping backtracking. So right here I basically just implement your usual standard run-of-the-mill Dijkstra's algorithm on like a matrix grid kind of problem. Originally I was thinking like maybe I would just go with like a DFS and it would be kind of like oh okay, as soon as I reach the bottom right corner I can totally return the distance that I did, or the depth first search that I would have done. And then I decided like Dijkstra's would probably be best here since it is kind of a shortest path. Like what is the shortest possible path you can get from the top left corner to the bottom right corner? So yeah, this is just basically me just speed coding a bunch of Dijkstra's algorithm boilerplate code while I internally argue with myself if I just want to go with the usual depth first search on a matrix kind of deal, or if I wanted to go with the Dijkstra's shortest path algorithm going through the matrix. And the main thing you have to know about Dijkstra's algorithm is it basically uses just a bunch of different data structures to achieve its goal. So we're basically using that hash set to track previously visited spaces in the matrix. We're using like a check bounds function to make sure we don't go out of bounds of the matrix and we don't return any like undefines, anything like that. And then lastly, we're using a min priority queue. This is another really cool thing that's just like a library that's included with the Leetcode JavaScript runtime environment that they have. So yeah, min priority queue just to like run through all the spaces optimally in like the best way possible. A distances hash map to check if like what my previous distances were to find like the best smallest possible distance. And then of course the visited hash set just to check whether or not I've visited past places, and then also a check bounds function to make sure I don't go out of bounds of the matrix when I'm trying to traverse it. Other than that, I just have like my standard DIRs array that I usually use. This is a cool trick where you can say like, okay, I know I'm going up, down, left, or right, so those are the directions I can just update my current row and the current column position that I'm in. And that's kind of how it's stored on the min priority queue. So I store its like priority, which is my distance, or whatever has the smallest distance possible on the min priority queue is the coordinates that I basically visit. Other than that, the coordinates that I visit are also just stored as like an additional array. So I'll have like my distance as like the priority of the min priority queue, and then the actual element that I'm pulling from is basically going to be that row column coordinate that I'm storing. And another thing that I'm embarrassed to admit is during the contest I was panicking a little bit because the timer just kept on going down and down. And my code just was not working for a while, but then I finally figured out that I forgot to add my while loop to check if my min priority queue is actually empty. So this basically means that Dijkstra's algorithm will run until my min priority queue has no other elements that could basically be dequeued from the queue. So yeah, like without that while loop, it only runs once. But with the while loop, then we're in business. So now that my Dijkstra's algorithm is finally working properly and actually returning some somewhat okay results, I decided it was now time to implement the collision detection for walls. So basically what I just did for this problem was if the symbol at a certain position is equal to a hashtag, that basically means that it's a wall. So I just add an additional if statement inside of my check bounds to see like if I can move to a space which is not going to be like a hashtag space, or if that space is actually a wall, in which case I return false. Which is perfect, so now the wall collision works perfectly with my matrix Dijkstra's traversal problem, so now all I have to worry about is figuring out how exactly I'm going to get the teleportation like letter coordinates to work properly for this problem. And since I was stuck, I decided to visit question 4 real quick. But one important thing to know about me is I'm kind of a Leetcode noob, and the hard questions really intimidate me, and they do not, put me at my safe space. So, so yeah, I just like browsed question 4 for just like a tiny bit. And I didn't really make an attempt at question 4. In fact, for this vlog, let's just say that question 4 is not mentioned. So I decided to go back to question 2 to see if I could get it to work. And I guess I had this idea in my head like, okay, so if the bubble sort doesn't work with like both for loops going left to right, what if I make the inner for loop basically iterate backwards? Is that going to somehow give me my optimal minimal amount of swaps that I need? So I tried that, and surprisingly, all of the test cases that were included with the problem description actually worked when I changed that code. So of course I was shocked when I tried to take a shot in the dark and submit the problem, and it's instantly failed because I still was not considering the fact that bubble sort was not inherently an algorithm that could return the minimum possible amount of swaps you would need to like achieve an assorted array. So yeah, I was pretty sad about that, but at least I had a failed test case that I could study the answer for and see like where my code went wrong. So yeah, I'd be stuck a little bit more on this problem because I was just putting way too much faith in the bubble sort algorithm. Also, for whatever reason, instead of like using JavaScript to find out what the expected digit sums would be, I decided to waste so much time in this contest by just like typing the numbers into a calculator to find the digit sums that way. I have no idea why I tried that instead of just putting it inside of JavaScript, but yeah, I put it in the calculator, try to type out 5 plus 8 plus 3, whatever, to get the digit sums expected for the number. And then, of course, I confuse myself when the digit sums versus like the swap count that they give me as the answer to the problem just makes absolutely zero sense, so I would be stuck on that for quite a while. So going back to question 3, what I decided to do for the teleportation point, since there's only like 26 possible letters it could be, is I created this data structure where I use a hash map to store an array of coordinates where a specific letter appears. So for example, if I have the letter A, I want to find all of its teleportation points. So I just basically push to that hash map the coordinates that would appear at A. So like A could be like 1, 3, 2, 3, 5, 10 million, like whatever. So I basically just have a hash map that stores a key value pair. The key is the teleportation point letter, and then the value can just be an array that includes a bunch of arrays representing the coordinates that that letter appears in. I do this kind of in a similar way that a graph traversal problem would work, and kind of in my head, because basically for every time I land on a teleportation point letter, I want to be able to just like iterate for loop style through its children to see whether or not each child could be a place that the player could teleport to. I decided to draw out some examples of the Leetcode problem to try to better understand what was going wrong with my solution. And I also decided to reread the problem description a bunch of times as well. And that's when I finally discovered that the act of teleporting between two different points does not actually contribute to your total move counter. So you could move from like point A to a different point A via teleportation, but that doesn't actually count as moving. So the Leetcode problem is only recording like when you move from one empty cell to another via walking versus actually doing teleporting. So teleporting doesn't contribute to your total move counter that you want to return at the end of the problem. So naturally I got overconfident thinking I solved this problem and clicked the submit button, but plot twist, I forgot about the whole having to return -1 thing if you're unable to reach the bottom right corner. Like for example, if the bottom right corner is surrounded by walls. So of course I got another failed submission. So naturally I fixed my code so that way it properly returns a -1 should it not be able to reach the bottom right position. I basically just did that by making sure all of my distances were initialized as -1 instead of 0. And of course I get another failed submission because why not? So I went back to question 2, and this is finally the point where I decided like maybe my count is actually incorrect since I did just type numbers into a calculator. So how about let's use the power of JavaScript, do a very basic like numbers array map to convert all of my values to my expected like digit sums that I want to like actually play around with. So I write that one-liner in JavaScript. I just console log it out so that way the Leetcode runtime can just give me back the digit sums for that failed test case I'm supposed to be expecting, and then I can finally draw it out in XCaliDraw and see like why my solution is going wrong. Of course, I still can't see why my Leetcode solution was wrong due to the bubble sort not being like the actual right algorithm for the job. So I decided in my panic to just destroy everything I've done, forget the bubble sort, and just try to use like a traditional custom sort function inside of JavaScript to get my expected array that I want to have. And I guess in my head I was thinking like, okay, if I just get the expected sorted array that I want to have versus the numbers array that I'm given, I can just somehow find the number of swaps that I want to do that way by just doing like comparisons between each different array. So now that I have the array successfully sorted the way that I want to be sorted for this problem, I just went ahead and used a for loop to keep track of how many swaps that I actually need to perform. So I basically just get the count of how many numbers do not equal the same as the number that's in the sorted array, and then I just divide that result by 2, basically. Like if you need to swap 2 different numbers together, that's basically one swap operation that you have to perform. So I got really cocky again, thought this would do the trick, submitted it, and plot twist, it did not work. You know, and I was running out of time on this problem, so I decided in one ditch effort I would try to change the floor to seal. Why that would help, I don't know. Sometimes that's the magic trick to solve other Leetcode problems. So I tried changing it to a seal, which basically just rounds it differently. And surprise, it didn't work yet again. So I went back to question 3, and I decided to fix up my algorithm a little bit to try to get it to work. So I decided to replace the -1s I was storing in my array with infinities. And then that way I'd be able to actually store the math min into my distances, like as Dijkstra's algorithm traverses this matrix. And of course I get a little bit confident that my test cases start to work, so I go ahead and click the submit button, and surprise, it does not work. In fact, it's even worse than not working now because now I have a time limit exception I gotta worry about, so that either means that my algorithm is just that inefficient, or it means that I somewhere have an infinite loop that I am just not catching. So since there is only 2 minutes left on the Leetcode contest timer, I decided the best thing, last ditch effort to try would be to just return out of my Dijkstra's algorithm function as soon as I hit the bottom right corner, and then maybe, just maybe, that would like help me prevent this time limit exception or prevent the infinite loop or whatever was going wrong with my code. So I decided to try to do that. Plot twist, it didn't work, but it was worth an attempt. And yeah, so I got a lot of failed submissions and only one question right on this contest, which was the easy question. So I definitely did not pass this contest. Definitely utterly failed. Please leave a like and subscribe for more content on this channel.